Again, this is Professor Zawolo. Today, we're going to be going over another section of the West African Examination Council Senior Secondary School Examination Mathematics for Liberian School. Today, we're going to be going over the coordinate geometry section, the coordinate geometry of straight lines, and today we're going to be focusing on the gradient. Actually, it should be the gradient intercept formula, because gradient and slope means the same thing, so it should actually be gradient intercept formula. Alright, we're going to make that correction there, gradient intercept formula. So, we're going to be going over how to find the gradient of a line in the XY plane and how to write the equation of a line in gradient intercept form and point gradient form. Two different forms of the lines. So, let's see how it works. First of all, the gradient of a line given the coordinates. So, if we are given 2 points on the line, say point A and point B, and A and B have to coordinate x1, y1 and x2, y2 respectively, then the gradient represented by the letter M is given by the change in y over the change in x, which is y2 minus y1 divided by x2 minus x1. And the gradient intercept form of the equation of the line is given as y equals mx plus b. Here, M is the gradient and B is the y-intercept, is the intersection of the graph with the y-axis. And then we have the point gradient form of the equation of the line. Say, for M, the gradient, and the point on the line which has a coordinate x1, y1, the point gradient formula would be this. Why do we call it the point gradient formula? Because we have the gradient here, which is M, and the coordinate of x1, y1 will give us the gradient point. So that's what we call it, point gradient formula. So we basically have two formulas for now. We have gradient intercept formula, and then we have also the point gradient formula. So then we want to talk about how we can use the gradient to tell whether lines are parallel or perpendicular, or how we can use the fact that lines are parallel or perpendicular to calculate the gradient. So for example, we say the gradient of parallel lines will always be equal. So if two lines are parallel, then they will have the same gradient. If two lines have the same gradient, that means the lines are parallel. And then we have the product of the gradient of two perpendicular lines is going to be -1. Or sometimes we say they're going to be the product of they're going to be the negative reciprocal of each other. Something I will talk about when we go into problem 3, -3, 6, and 5, -2. So to find the gradient of a line, we must use a formula. But first thing, let's write up our points. -3, 6. And the other point we have here is 5, -2. Now, why do we write this up? So that we can do this, x1, y1, x2, y2. Then we'll write up the formula, which is given by y2 minus y1, x2 minus x1. Not necessarily negative, no. You have to look for them each. What is y2? -2 minus, what is y1? 6. What is x2? 5 minus, what is x1? -3. So what do I have? -2 minus 6 is going to be -8. 5 minus -3 is going to be 8. So if we divide here, our gradient here is -1. Now, next we want to go over find the gradient of the line defined by this. Find the gradient of the line when we are given the equation. Okay. So to find the gradient of a line when we are given the equation, we can do something. We can rewrite this problem in gradient intercept form and then identify the value that is in the position of the gradient. So to do this, the gradient intercept form is what? What is the gradient intercept form? Gradient intercept form. So we have y equals mx plus b. So if I can rewrite this, so we're going to rewrite 3y equals to 2x minus 6. Well, to get the y by itself, I simply have to divide by 3, divide by 3, divide by 3. So I have y equals to 2 over 3x minus 2. So what's my gradient? My gradient is right here. This is the value that is in the position of m. So my gradient, represented by the letter m, denoted by the letter m, is equal to 2 over 3. So first of all, since the new line that we're going to be writing is parallel to a given line, we must identify the slope of the given line. So step 1 is to rewrite 3x minus 2y minus 8 equals to 0 in gradient intercept form. So let's do that. 3x minus 2y minus 8. So we need to get the y by itself. Now I'm going to do an interesting way here. I will do plus 2y plus 2y. That will cancel. So what I have here is basically 2y is equal to 3x minus 8. Now I hope there's no confusion. All I did, so I will have 3x minus 8 equals to 2y is the same as 2y equals 3x minus 8. Now to get y by itself, I divide by 2, divide by 2. So I have y is equal to 3 over 2x minus 4. Now what I need to take from this is simply the gradient. So the gradient here is m equals to 3 over what? 2. Because my new line is parallel to this line, so then the slope, the gradient of my new line must be the same as this. So the gradient must be the same. Then I must use the point that is given to me, which is negative 3, 7, and then I can find my b to be able to write this. So now, what I'm going to do, I'm going to write y equals to mx. But before I do that, let me do this. From here, I see that I have an x value to be what? Negative 3. I have one y value to be what? 7. So if I substitute these into y equals mx plus b, I will see that something will be missing. So what is my y? My y is 7. What is my m? My m is 3 over 2. What is my x? My x is negative 3 plus b. So now I want to have b that is missing. So what then can I do? Well, I can have 7 equals to 3 times negative 3. That will be negative 9 over 2 plus b. And I'm going to come right over here, trying to squeeze things up here. So now I have only b missing. So how do I do this? I can solve for b by adding 9 over 2 to both sides, plus 9 over 2, plus 9 over 2. And if I do this, I'm going to have it, I can rewrite 7 as 14 over 2, because 14 divided by 2 is 7. And then I have this 9 over 2. I hope you understand the reason why I did this. And I'm going to just erase this problem over here. So then I have to come down and rewrite it. And so because I want you to understand it clearly, so in fact, I'm going to start here again. I'm going to do 7 equals negative 9 over 2 plus b. And I added 9 over 2 to both sides, added 9 over 2 to both sides. And I performed fraction, which I did say was going to be 7 plus 9 over 2. I can do 14 over 2. It's just a basic fraction skills. I'm doing 14 divided by 2. I'm trying to give them the same denominator. And so now that I have the same denominator, I have 23 over what? 2 is equal to b. Now that I know b, I earlier calculated m to be 3 over 2. Therefore, I can write my equation in gradient intercept form by substituting appropriately. Y is just going to be y because it's general. M is 3 over 2. X is going to be x because it's a general equation. Plus b, which is a constant value, is going to be 3 over 2. Now, we can do several things. This is the gradient slope form, gradient intercept form. I can put this in standard form. Multiply everything here by 2. I can have 2y equals to 3x plus 23. I can move the x across and have minus 3x from here, minus 3x from here. I can have negative 3x plus 2y equals to 23. Now, something about not having the leading coefficient negative, I can multiply everything by negative 3 and have 3x minus 2y equals to negative 23. So all of these answers are the same. They're just written in different forms, and I want you to familiarize yourself with the difference in the different forms, but they are all the same. So now number 4, we have to write the equation of the line through this point 1, 2, and perpendicular to the line defined by this. So once it has to do with perpendicular, parallel, so what we need to do is to see if we can find the gradient. So let's take this line, 4x plus 2y minus 5, rewrite to identify the gradient. So that means we must get the y by itself. So we do 4x plus 2y minus 5 equals 0. Again, I could move the 4x and negative 5 on the other side. I could move, so yeah, in this case, I'll do that. I'll minus 4x and I will add 5y here, 5 here. So I will add 5 here and then minus 4x here. Because I don't want my y to be negative, so I have 2y equals to what? This is going to be 0 equals to negative 4x plus 5. And then I'll divide by 2, divide by 2, divide by 2. So I have y equals to negative 2 over 1 x plus 5 over what? 2. Now I deliberately, negative 4 divided by 2 is negative 2. But I deliberately left it like this because since I'm dealing with a problem in which the lines are perpendicular, so since the gradient here, the gradient here is what? Negative 2 over 1. We know that since the lines are perpendicular, the product of their gradient must be negative 1. So that means negative 2 over 1 times the gradient of my new line, which I don't know, must be equal to negative 1. So how can I find that? Basically, how can I get 1? It's going to be the reciprocal of this. What's the reciprocal of 2 over 1? It's 1 over what? 2. If I multiply negative 2 by negative 1, I'll have that. So basically, the gradient of my line, let me call it the new line, is m equals to 1 over 2. If I multiply this by the gradient of the line I was given, I would get negative 1. We also said that instead of looking at it as negative 1, you say it's going to be the negative reciprocal of each other. The reciprocal of 2 over 1 is 1 over 2. The reciprocal of 1 over 2 is 2 over 1. Negative reciprocal means 1 is positive, 1 is going to be negative. So now that we know the gradient is m, which is 1 over 2, we can take our point given to us, and the point we have here is 1 comma 2, which means x is going to be equal to 1, y is going to be equal to 2. We can substitute them here. Y equals mx plus b to be able to find our b. So y is what? 2. My m is 1 over 2. My x is 1 plus b. So what I have here is going to be 2 equals 1 over 2 plus b. And if I multiply everything by 2, I'm going to have 4 equals 1 plus 2b minus 1 minus 1. I'll have 3 equals 2b divided by 2 divided by 2. I have b equals 3 over 2. Therefore, my equation will be y equals to m. My m of my new line is 1 over 2x plus my b is what? 3 over 2. Now, I'm just going to introduce you to another way of doing this quickly. Now that we have the the point to be 1, 2. I will do x1, y1. Can you guess which way I'm going to get you to try to do this? And then my gradient is 1/2. I'm going to take this on the approach of a gradient, a point gradient method. So let's go. I'll do y minus y1 equals mx minus x1. Let's do the substitution. Big Y is y. Y1 is going to be 2 equals m is 1/2. Big X is x minus x1, which is 1. Let's see what we have here. Y minus 2 is equal to 1/2x minus 1/2. I'm going to add 2 here, add 2 over here. So I'm going to get y equals 1/2x. And when I do this, I'm going to have plus 3/2. So it's basically the same thing. But also, what I'm going to do next is to put it into a general form, a standard form. If I multiply everything by 2, I'm going to have 2y equals, so I'm multiplying this by 2, I'm multiplying this by 2, I'm multiplying this by 2. These 2 will cancel. So I have 2y equals to x plus 3. And then I can move the x on the other side. And I will have negative x plus 2y equals 3. That's another form of this equation. And then if I take the opposite, I will have x minus 2y equals negative 3. So all of these answers, everything that I have in this form are all of the same answer written in different forms, all of them. And no matter the method that I use, I still end up with the same thing. So thank you. This is it. It's the last problem we have to solve in this section. Find some time, get online, open an account on our WAEC prep link at our website, www.LIberia.org. Get to do some practice. Also, don't forget to subscribe to our YouTube channel so that you can have more access whenever, so that you can immediately know when we upload new videos. So thank you very much. This has been a production of the field. Field is committed to making sure that every librarian shall have access to content, quality content instruction. Thank you very much.